Okay, in this video I'm going to teach you about writing a balanced acid-base reaction. And so, as we have seen already in our notes, an acid is something that begins with hydrogen and it has an anion. So your positive hydrogen, your negative anion, this can be any nonmetal. A base is going to have a cation as well. This could be any metal. And it's going to have hydroxide as the anion. This is just like our double replacement reactions. It's just a special kind. Our cation over here, hydrogen, is going to bond with our anion over here, which is hydroxide, and the cation from the base is going to bond with the anion from the acid. Remember, we always write our cations first. So on this side of the arrow, we're going to make those combinations. It doesn't matter which one you write first, but every time H and OH get together, you could write it this way, but if you recognize this formula, can also be written as H2O because it is water. Our other formula is going to be made up of our second cation, second anion, and looking at the periodic table, you can determine their charges. K is in group 1, that's a +1. Br is in group 17, it's 1 away from being stable like a noble gas, so it's going to gain an electron and be -1. So a +1 and a -1, they balance each other, and remember, always write the positive one first. Okay. In this case, my entire equation is balanced because I have 1 potassium on each side, 1 bromine on each side, 2 hydrogens, and 1 oxygen on each side of the arrow. Now if we move down to this one is now my base, so it doesn't matter which order, but this is a base. We have the cation, which is calcium this time, and we have our anion, hydroxide. The acid here, cation is hydrogen, anion is chloride. Alright, so we're going to do our combination again. Cation with this anion, this cation with this anion. I want you to ignore this 2 for now, okay? Hydrogen and hydroxide are always going to get together, just like up here, to make water. So one of our products is automatically water when you have an acid-base reaction. The other product is a salt. So we're going to have calcium together with chloride. Calcium has a 2+ charge, chloride has a 1- charge, and we can tell that from the periodic table. So if we put those two together, we're not going to get CaCl because the 2+ from the calcium would come down with the chloride to make CaCl2. The final thing on that one would be to balance the entire equation. On this side of the arrow I have 2 chlorides, and over here I only have 1, so I'll have to write a 2 in front of HCl to balance that. And then if I look at my total hydrogens, here I have 2 times this in here, plus 2 here, so that's 4 total hydrogens, but only 2 on this side. And there we go. The easy way to balance an acid-base reaction is to balance your anion first, and then balance your hydrogen, and you should be able to get it done. Okay, here, Hi and AlOH3. Okay, same thing, our acid and our base have a cation. Our acid and our base have an anion. Okay, the H and the OH together make water, so automatically we can write H2O. Okay, then we have our aluminum and iodine need to make a compound. Again, you ignore this number. This number does not come over here for any reason. We just need to balance charges. If we look at the periodic table, aluminum has a +3 charge, iodine has a -1. So again, we're not going to have Al(I) because a +3 and a -1 don't balance each other. So that 3+ charge from aluminum would have to come down and be written with the iodine. Okay, now here, balance that anion first. We've got 3 iodines on this side, only 1 over here. So I'm going to put a 3 in front of Hi. And then if I look at my hydrogen, 3 times hydrogen here plus 3 times hydrogen here is a total of 6. On this side right now I only have 2. So I need to put a 3 here to get a total of 6 hydrogen. And that is how we write acid-base reactions.